Okay, to make a word equation, you want to focus on the chemicals within the problem. You don't want to focus on all the extraneous words that just really aren't going to help you a lot, okay? So like in this first example, you have nitric acid reacts with barium hydroxide to produce barium nitrate and water. So it gives us the formula for nitric acid because we don't know how to do the formula for an acid yet. And it says reacts with, so that's a plus sign, with barium hydroxide. So barium is Ba and hydroxide is OH. Now because this is a ionic compound, you have a metal and a non-metal, then you're going to have to do some swap and drop. So barium is 2 plus, hydroxide is 1 minus. So when you swap and drop, you get BaOH2. Okay? And then you can get rid of your charges up here. You don't need them anymore. All right? And then it says, next part of the problem, to produce. So you're going to draw an arrow. And then barium nitrate. So that would be Ba. And nitrate's polyatomic, NO3. Again, this is an ionic compound, so you need to swap and drop. Barium is 2 plus. Nitrate is 1 minus. So when you swap and drop, you get Ba, NO3 in parentheses, 2. And then we go back to our word equation, barium nitrate and water. So and tells us a plus sign. And then water is H2O. Okay, so that's how we do that first one there. All right, the next one says calcium sulfite decomposes when heated to form calcium oxide and sulfur dioxide. So calcium sulfite is going to be Ca, and then sulfite is SO3. And then again, this is an ionic compound, so we're going to need to do our swap and drop. Calcium's 2 plus, sulfite is 2 minus. So, all right, and so these charges are just going to cancel each other out. So it just ends up being CaSO3. All right, decomposes, so that's a hint. It's telling you straight up this is a decomposition reaction when heated to form. So forming means that's our product. So we just got an arrow. We're going straight to products here. Calcium oxide, so CaNO. Again, ionic compound. So get your charges. Calcium's 2 plus. Oxygen is 2 minus. So if you look, those charges are going to cancel again. And then we're going to have, and it says calcium oxide and, so that's a plus sign, sulfur dioxide. Sulfur dioxide, SO2. Okay, now there's no swap and drop needed for the SO2 because that's a covalent compound because it has a SO. Those are both nonmetals. So you don't need to do any swap and drop on covalent. Remember, they use the prefixes, no swap and drop required. Okay, there's your equation. Of course, I'm not balancing any of these, but you would need to go ahead and balance them. I'm just making sure that you can actually write the actual formula and write the equation itself, but then you would need to balance them. So if we look at the next one says iron reacts with sulfuric acid. So iron is Fe. It's by itself. When anything's by itself, you want to check and make sure it's not a diatomic element. Fe is not diatomic, so we can just move on. Reacts with tells us we need a plus sign. Sulfuric acid, we don't know how to do acids yet, so we have the formula right there, H2SO4. To form, so that means that we need an arrow. We're going to have some products. Iron 2 sulfate, so iron and sulfate. These are ionic, so you're going to need some swap and drop. Iron 2, Roman numeral 2, tells us that this is 2 plus, and sulfate's the polyatomic. Sulfate is 2 minus charge. So you see that those charges, again, they're just canceling out. Okay? And then iron 2 sulfate and hydrogen gas. And means you put a plus sign. Hydrogen gas, that'd be H. Again, anytime anything's by itself, check and see if it's a diatomic. H is a diatomic, so we're going to put a little 2 there. And then you would ensure that the equation is balanced. This is actually already balanced. All right, the next one we have here is ammonium burns in air. So ammonium is in H3. Burns in air. That's telling us that we've got some oxygen going on here. So that's going to be plus O. Oxygen's O. It's by itself. So you want to check and see if it's a diatomic. It is a diatomic. So you're going to put the 2 there. Going back to ammonia, it gave us the formula. So there's no need to swap and drop. So burns in air, 2 form. So 2 form, we're going to have our arrow. Nitrogen dioxide, so nitrogen and then oxide with 2. That's our prefix for di. And then plus water. Okay, and water is H2O. Again, nitrogen dioxide, that is a covalent compound. No need to swap and drop. Just write the formula as is. Okay, and then you would need to make sure this equation was balanced. Okay. And our last problem, we've got carbon disulfide, so that's going to be carbon, S2, burns in air, so plus air, O, and again, check to see if it's a diatomic, put the 2 there. The carbon disulfide was covalent, so didn't have to swap and drop. To form carbon dioxide, so CO2, covalent, no need to swap and drop, and sulfur dioxide, SO2, covalent, no need to swap and drop. And again, you would make sure that you balanced all of these equations. So I hope that this little tutorial was helpful for you. Basically, I just did some practice problems, but hopefully it was helpful.